So this is the third lecture of our series. So in this video, in this lecture, we have to find resistance across A and B, and this question is very similar to our previous questions, but in these questions we have one more complexity, that this in this node between we had a short circuit, but now we have a resistance. So this is the modification we have done in these questions. So let's see how we will solve it. So we'll just redraw our circuit, and we'll give the name of this short circuit is here. So this node and this node is same, so can we call it this node is A, then we can call it this node is also A. But in this case, this node B is connected to two resistors, so we can't call this node is same, because there is a R. So this node and this node is not similar, so we can call it we just call it C, so another node. Okay, so then just redraw our circuit. Then for simplification, so just see that between A and C there is one resistance. Between A and C there is one resistance. Okay, forget about this part. We have done with this resistors, right? Let's see if this register between A and C there is one more resistance. Between A and C there is one more resistance. This resistor also one, this resistor also one. Okay, so we have connected it. Now between A and B, so B node is there, we just call it B node. And between A and B there is one resistor A and B, so we draw it, right? Forget about this part now. We just applied one node here, we just assume one node here, and we connected it. And now C and B, in between C and B there is one resistor C. This node is C, and B there is one resistor, right? So I will draw it, will draw it for you again. This is A node, this is B node, and this is C node. You can I will redraw it. Between A and C, between A and C there is a resistance of AR. Between A and C there is one more resistance R. Between A and B there is one resistance. Between A and B we can call it O resistor. And between C and B there is one resistor, right? So we have to calculate resistance across A and B, right? So just I have shown this how we will redraw our circuit. Just so we will simplify this circuit. You can further simplify this circuit also, and this circuit and this circuit is also same, nothing changed. Just redraw our circuit. So okay, so I will solve this circuit. So we can convert this delta into star for simplification, or else we can this resistors are in parallel, so we can make it parallel also. This R is R by 2, this R, right? These resistors are in parallel, right? We can equivalent it R by 2, and this R and this R. So the further simplification is that this A terminal, B terminal, this is R, and R is 3 by 2 R. Okay, and for equivalent resistance 3 by is R equivalent is 3 by 2 into R plus 3 by 2 plus R is equal to 3 by 2 R square plus 5 by 2 R is just 3 by 5 R. So total resistance equal to 3 by R between terminal A and B. So R equivalent is 3 by 5, right? So this is the solution. Okay, so you are not able to see. Okay, so this is the solution for that. What we did, we just parallel it 3R and 3 by 2R, right? And we got 3 by 5R, right? So this is the solution of our these questions, right?